Welcome everyone to Mark Voids a Warranty. I'm Mark, and I'm going to void a warranty. Today we've got an exciting project for you. This is an infrared reflow station. It's kind of I would say introductory level, but it's got a few different functions and things that it can do. But basically meant to help you rework a circuit board. If you know there's something bad on it or there's a bad connection or whatever, you've got to fix it. And that's what you allegedly use these for. So it basically has, let's call it 3 parts on this one. Some have more. One is this, which is an infrared light, and you can move it up and down, and you can change the, let me unscrew it here. Nothing too much about it, but you can basically change the aperture. Is it just flipping around? It doesn't feel like it's screwing off at all. Okay, well, I'll have to work on that. I never prepare for these because that would make me look more professional and knowledgeable than I am. Down at the base, we've got a ceramic heating element to preheat the board. And it also comes with a soldering iron. So all sorts of fun stuff to smash today. We're going to have a good time. As we go through, if you do have any questions or comments or concerns or anything along those lines, please ask them in the chat. I'll try to keep an eye on that. And as things come up, cover them. Now, what has this done to offend me? Let's say it looked at me funny. I don't know. Actually, no. I want this mechanism out of it for another project. And I don't actually like the performance of this particular machine. So it's been sitting on a shelf for a couple years. It's probably going to stay there if I don't do something with it. So that's what's going on with it. So let's start by taking it apart. I'll change views here. We're looking down on that camera. So let's just, well, actually, you know something, might have to pull that plastic piece out first. Whoop. Okay, well, that's out. There we go. And unscrew this lift post. And it looks like that might be bolted on to the bottom. It might be a minute before we get any further. On the back side, you know, you've got connections for the heat lamp and the soldering iron, a fuse, a master on-off switch, and a big fat bolt. Wonder what that's about. Front side, we've got all of these 7-segment displays connected to the various thermal controllers. So I guess we'll just start going. It's quiet out there in TV land. No comments yet. That makes me feel lonely. It would make me feel less lonely if you commented. All right, so all I'm going to do is go around and loosen these case screws. They feel like they're spinning. That's never good news. Oh, and that's stripping. That's not a, and my number 2 is in use elsewhere. Let's see if I have another one over here. I do. You never want to strip out your screw heads. It makes life so much more difficult. Okay, so these are unscrewing. The ones in the center connected to the ceramic heating element were not coming out for whatever reason. All right, while I'm doing this, while I'm taking this apart, let me tell you a little bit about Teach Me PCB. That is a project we've got going separate from Mark Voids a Warranty, where we all get together and build stuff. Our last project was a macro keypad that you could, you know, program the keys to type shortcuts, put in a mouse, and you can do whatever you want. It's a neat little project based on the Raspberry Pi 2040. Now, a lot of the members who got their first board back decided they wanted to make some changes, and they're making them now. So it's kind of scattered when we're getting stuff back now. But we are starting to get some boards back, and we'll share those with you soon. Also upcoming is a design contest that is going to be open to everybody. And details will follow, but it's going to be a lot of fun, I promise. So much fun, we might not even have to offer a prize. The design is that cool. So, or the contest is that cool. All right. Let's see what we've got going on over here. Almost there. Let's see, let's see. Okay. Feels loose. There's one left that I missed. There always is. For these larger projects, I think I need an even bigger camera. Something that really zooms out for you. Okay. Oh, this is cool. Wait till you guys see inside. This is neat. So on top here, we've got a pretty heavy, thick piece of, I guess, aluminum. It could be steel. I'm guessing aluminum. It's non-magnetic. The weight could be coming from this guy. And see, that's what we have on our back side. We had those screws, so we need a appropriate nut driver. That'll do it. To loosen these things up. We've got some aluminum tape on the back here. Wires covered in fiberglass filament. I mean, one of the things I don't like is it looks like this thing is bent, and I don't know that it was supposed to be. I don't know what happened there. What could have happened there? I'll show you what I mean. Always difficult to know how things are designed or supposed to be designed. There we go. So here is our ceramic heater element. It's gasketed into that top plate and then taped past that. This is the part that I'm curious about. See how bent that is? Maybe it's supposed to be that way, maybe it's not. It's just interesting. Because they used these pieces are turned up to give this mechanical strength. I don't know. Don't know. But we'll stay on it and see what else we can learn. All right. So this is the base plate for the stand. And I'm going to set that aside because I'm going to use that with the stage lift in a little bit for another project. All right, take a look in here. Check out that power transformer. That is a coil, my friends. That is cool. We've got a switcher here on a big fat heatsink, and I guess that's just screwed down. So the big bolt we saw on the other side is likely holding this transformer in. We've got a board up front that is the control panel with all of its fun stuff and a bunch of 7-segment drivers. We've got a power board and a exhaust fan. I don't know, that's a 40 millimeter by 30 or something. It's pretty thick. All right, so that's kind of the overview. Time for more Mark Smash. Mwahaha. Do I need cutters? I think I need cutters. Are they handy? They are. Lucky me. So it's kind of interesting. It looks like they kind of went a little overboard with the fiberglass covering here. I don't know how much heat they anticipate, but man, they covered everything. They don't want a fire out of this. I like overboard. But one of the things you're not supposed to do is put your zip ties on so tight that you're crimping the insulation and damaging it. I mean, you guys might not be able to see that on the video, but that thing was cranked. They really had this stuff tied in. All right, continuing our teardown. We've got a lot of stuff that is unfortunately all soldered in. Not a whole lot of connectors to disconnect things. We're just going to have to figure out what they do and then cut them. That's always disappointing. Oh, this is kind of interesting. So up here near the top where they do expect the heat, they figured the fiberglass wasn't enough and they covered the wires in ceramic beads. I haven't seen that before. That's clever. Neat, neat. Okay. So let me get you a better view. Boom, boom, boom. Get a couple things out of the way, maybe. Like my screwdriver set. All right, so this is the wiring, the two that I'm moving right now, for that heating element. And it looks like it's tied to a connector marked solder. All right. So that's one. And then the other one goes straight to the hot side input. So this thing is connected straight to the line. So this is 120 volts going into this thing. So this thing's meant to get hot. And then out the other side, we've got something, you know, whatever that solder thing is. Why? I don't know. The other side of that solder thing, I don't know that they were connected, goes to the master arm switch. So weird. And then coming back over here, we've got a really tiny connector that goes to... So this must be the thermocouple, and it transitions into this little guy, and this little guy is marked something. Looks like solder as well. Huh. And it's all glued in, of course. All right, we would have to be careful, but that heating element, this guy right here, he could be used somewhere else. I don't know where, but a preheater is never a bad thing. All right, so now we are back to a slightly wider view. So now we're back to a few more things. They do have glue here on these connectors, but it's not doing much. So that just disconnects the fan. That's no biggie. This is connected to the IR heat lamp. And it goes to this, I forget the name of that type of plug. From the IR heat lamp, which we're not going to reuse, it goes to a pin marked AC 15 volts. So that's free now. And then IR heat lamp goes from AC 15 volts into that giant toroidal transformer over here. So that's free now too. Okay, we're still working our way through here, trying to make sense of things as we go. If you have questions as we go, please feel free to ask. I am more than happy to answer them. What else? What else? So that frees up our IR heat lamp. Next, we've got the soldering iron. So the soldering iron has a pin from the toroidal, so that must be giving us power. It's green colored. It goes from green into the side marked AC 24 volts. That's free. So then we go into the soldering iron, come out of the soldering iron, and then we've got two more wires that connect to, one of them's ground, or is that just one ground? It's one ground. So we've got a wire coming off that grounds out the soldering iron. That's always useful. And then we've got two wires that connect to another device that must then go into the iron for the thermistor setting. So for the thermistor connection. Okay, we are making progress. Coming off the toroidal, there's another two wires, red ones. And these red ones go to our master on-off switch. Master on-off switch goes to the, I believe that's an IEC connector, is what those are called. Comes out of the IEC connector, goes to the fuse. Comes out of the fuse, goes to the switch, comes out of the switch, and goes to AC 220V. All right, we have almost disconnected everything. We've got another wire off the inductor that says goes to lamp, black. That's free. Two yellow wires off of the toroidal inductor that go to something, and the marking is obscured. I can't see it. So that's free. And then we've got three thick wires that go off to this guy way over here. So we've got a switch there. It's a big fat one, big fat heat sink. Whatever it does, it is designed to handle a lot of current and a lot of heat. Okay. I will save that fiberglass for a rainy day. You never know when you can use fiberglass insulation. Probably should get a spool of that at some point. We've got one last green wire off of the toroidal. It's marked iron. All right. All sorts of fun to be had. Oh, it's a quiet day in the chat box. Last week we had a party. You guys must not want to see what's inside my iron here. All right, so now we got to get these boards free. And they're covered in glue, so they're not going to be easy. But I've got a trick. Van pliers. So these things are cool. They actually can grab at the end of a screw. So if you strip out or you can't get to whatever it is that you're getting to, you know, like for example, somebody's covered it in some type of enamel. I really don't know how else to better describe it other than enamel. You can get it out. Let's see now. Should be close. Nope. It's going to ride the whole ride like this. Okay. Good news is there's only 4 of them that we have to do that to. So while I'm doing that, we can talk for a minute about soldering on these connections. Connectors are expensive, unfortunately. So one of the, you know, depending on how much your labor costs are, it can sometimes be cheaper to just solder the wires in rather than use connectors. You also don't have to worry about them, you know, popping out during shipping or anything, which is probably why they use this enamel. And to be fair, things didn't pop out during shipping. But all it seems to be doing at the moment is aggravating me. Didn't they know I'd be doing this to their product? But yeah, these vamp pliers make this particular part of the job very easy. I like them. I would say you should get yourself some. But if you don't, that's okay too. Come on now. We're almost there. Okay, one more. We're making progress. But yeah, I wish they wouldn't have done this. A little dot would have probably been sufficient. Covering the head gets you nothing. It's putting the glue... Oh, did I just break that glue out of there or no? Nope. It's putting the dot of glue to connect the head to the board that gets it to you. Filling the holes of the screw head, that doesn't do anything. Okay. One board free. It's a clean looking board. Looks like we've got some interesting design features to take a look at. So we'll set that aside for now, keep taking things apart, and we'll come back to it. I'm going to leave the fan in place for now. I don't think we need to necessarily deal with that. We've got this giant heat sink. See if that, does that get it out? Nope. So thermal paste and whatever this FET is, acting as a big fat switch. We can maybe look and see what that part number is under the microscope. And I don't know if that will come out or not. Yep, there we go. So they just screwed right through the vent hole. That's a little slap shot. I'm not gonna lie. It does solve the problem and it's fine, but it just looks lazy. Okay. Now, if we're able to, see if I can pop this toroidal free. There it is. It's got a little rest pad to be on. That is a heavy transformer. If you hit somebody with that transformer, they are going down. I'm telling you. Things like a heavy hockey puck. Okay. We don't need these wires. So I'm just going to get these out of the way so they don't have to deal with them. All right, so now we've got to see if we can get this free, and I don't know that we can in our allotted time. It's going to depend on how many of these pop out. Oh, we got lucky. There's one. Oh, we got lucky. There's 2. Luck. Come on. All right, there's 3. Almost. Are we going to get 4? Not going to get 4. Okay, we got 3. That gives me hope. Number 4 is loose. I guess before I start doing that, I should see how many more of these I'd have to deal with. I'm going to come back over here, and we're going to pop the IDC connectors. Get those out of the way. Don't really care about them anyway. There's 4. Cross your fingers, Internet. Okay, here's 5. It's loose. Gonna have to pop those JST connectors. Got 2 more back here to deal with. And I've got a sad cat. There's little Mr. Chester waking up from his nap. Hi, buddy. Oh, the life of a cat. All right, come on, big guy. We're getting there. We're getting there. I want to say that one's done, and I want to say that one's done, so we're down to just 1. We have time for that. But yeah, I would describe that as a fingernail polish. Is, I guess, the best thing that I can think of to describe it. Oh, that one's just hanging in there just ever so slightly. There it is, I think. Did we get it? Did we get it? Come on. Did we get it? There we go. We got it. We're done. All right. Set that off to the side. We have the boards. We have the thing, the heat lamp, which is kind of coming apart. So I'll go ahead and take that fan assembly off. So we've just got a heat sink and a big fan on top. And we've got the soldering iron. So let's start with the soldering iron. These things are pretty typical, and I really wish I remembered. I mean, I don't know that that's a 240-degree DIN. It could be, but I don't really remember the sizing. It could be a 240-degree DIN connector. These things are a pain and a half to solder. If you ever have to terminate your own, man, I had to do that in a recent wheelchair build, and I can't even begin to tell you how frustrating that was. I eventually bought a little cheap chuck for like a little tiny Chinese import lathe, you know, the ones that are maybe 12 inches long. I bought a chuck for one of those and used it to hold the connector, and that was the only way I could actually get those things soldered. So we're going to take a quick look. See how these guys did it. Okay, let's see here. Why isn't that coming apart? So there's the strain relief out the back. Did it snap in? Oh, there's a crimp. Ooh, I might not be able to get this apart. Oh, there is a teeny tiny screw head. That might be the difficulty on this one. And I can give you guys a better view. This is what I'm looking at. Okay. There it goes. There it comes off. So you've got these, I mean, this is actually much easier than the one I had to deal with. So this is a solder into recessed, you know, it's got all these separators. This is actually a nice one. That's much nicer than the one I had to deal with. So, anyhow. So down at the bottom side, we've got that. It's actually a pretty nice connector. Got a string relief up at the top side. Up at the top, we've got a relatively standard iron setup. You've got a retainer, the solder iron tip, and a problem. So this is going to end up being the heating element and thermocouple. And the solder tips almost always have a loose connection. I mean, there's a ton of play. This does take the play out of the head to the handle, but there's still airspace inside. And air is a great insulator. It's a horrible conductor of heat. It's like 4 watts per meter Kelvin. It's not good at all. That means that the temperature that is in here isn't necessarily the temperature that's over here. It can fluctuate by quite a bit. If you ever pull a thermal camera out, you can actually see that. You know, if you paint this with white out so it's not shiny and reflective, you can see the temperature difference. When we did some experiments a couple weeks back, you know, we were looking at, I don't know what it was, like 20, 25, 30 degrees Celsius. So quite a bit. All right. So the heating element has a, you know, a protector, a guide. The iron tip sits on that. And inside here, we've got connections to, this is a ground connection that connects to the electronic or the metallic parts of this. And then inside that little ceramic element, you've got a bunch of nichrome wire. And somewhere hiding in there is a thermocouple. I don't know if I'll be able to find it. I think it's internal. It might even be formed around it. Yeah, I don't think we're going to get that thermocouple out. Maybe. Let's see. Oh, cut the nichrome. I don't know. It's so small I can't even see it with my bare eyes anymore. So I'm trying to look at it on my monitor. All right, I'm going to go with no. No, I cannot. So one wire is the nichrome return, and then the other two are the thermocouple. Trouble is, it doesn't want to be found. So I just snapped that little thing in half, peeling away the nichrome, and there it is. You guys, I don't know if you guys can see it or not, but it's that little connection right there. So that's right at the tip, but again, there's airspace. There's a lot of airspace between the tip and, I mean, it's actually this one. But there's a lot of airspace in there. And that leads to some uncertainty in your iron temp. Anyways, That was fun. Next up, we've got Senior Heat Camera. Wahaha. Let's see if I can mute those notifications for you. There we go. The computer thinks I'm idle. I'm not idle. All right, so here we've got just a protective jacket sleeve and 4 wires. 2 were for the fan. The other 2 are high current. They're actually really quite nice. They're silicone wires. So I'm going to cut them and get as much of those as I can. So we've got a metallic gland of some sort. All right, now how is that connected? I'm looking silly here. All right, let's see if we can't find the correct set screw size. First try. Ha ha. That's right, folks. I get paid to do this. All right, I don't see a... So if it's... Oh, it does screw. I just didn't screw it far enough, so it does screw on. So we've got a lamp that puts out some infrared heat, what looks to be a gold reflective surface. Gold does a great job of reflecting heat. It's one of the reasons that it's chosen for chests like this. And then a replaceable halogen lamp, I think it is. Now, maybe not that replaceable. But that's pretty much it in there. I think I'll move on since we are starting to run short on time there. But you've got a connector for the lamp. Looks like we might have to take out the retaining ring there to get the lamp itself out. I don't think it's going to come. I think that lamp and reflector are all one big part. So anyhow, let's use our remaining time together to take a look at these boards. And we'll put that guy back. All right, so these folks went with individual 7-segment displays instead of a display module for whatever reason. These are pretty standard tactile switches with red and blue buttons on them. So they just calculated and figured out where these things went so it would poke right through the base. We've got red and green LEDs. And then on the back side, I'm assuming that each one of these is just a serial LED controller. Let's take a look on Mr. Microscope. Is that microscope? Huh. Why is the microscope not active? Do we have power? We have power. When in doubt, turn it off and on again. Nope, we do not have microscope today. Oh, wait, nope, there it did. Power did it. Just had to give it a second. Nope, it's off again. Oh, no. We must have bad power or a bad connection. Try it one more time. Okay. Nobody breathe. And then we lost it. Okay, I'm going to have to troubleshoot that, folks. We're having intermittent microscope issues that I can't troubleshoot while we're live. So, we'll figure that out. All right, so, but based just on appearances, it looks like all we have here are 7-segment display drivers. 3 of them. And there's a good chance, since we're not seeing traces go in everywhere. Well, we are. There's 3 to each one. So we could have a parallel SPI bus. If we knew what the part numbers on those devices were, I'd be able to tell you. And then we've got some connections coming back for switches and for, well, the 3 are probably for the switches. So anyways, this is just a display. It's a custom board just for running the display, and then it takes all the data and it sends it off. Oh, that'll tell us what we want to know. Ground data, output enable, looks like a strobe pin maybe, and a clock pin. And then on the left side, I can't really make those out. AO3, switch 2, AO2, AO2, switch 1, AO1, AO1. So it looks like those might be maybe the powers, but why would they be separate? I don't know. Anyways. Next. So connecting from there, the display goes to these guys. Those are easier for me to read. So it looks like we've got +5 in ground, so that's how we're powering things. The switches each get their own. Oh, I bet you that's the common of switch, and then minus and plus. So if I'm guessing, SW2 is the common connection on switch, or I'm sorry, SW3 would be the common connection on S3, and then you have a button connect to either AO3 plus or AO3 minus. I could be wrong there. But then, no, that doesn't make sense. That doesn't make sense. You wouldn't run those to I/O pins. That'd be a waste of pins. And then how are they turning the LEDs on and off for the lights? I guess they could use an extra segment, use the dots from that. I don't know. Don't know. We've got a little bit of power circuitry. So you've got, could be LDOs. I'm not really sure. I can't see the lettering. But you've got some big reservoir caps. See if we can see a value on there. 10 microfarad, 470 microfarad, 50 volt caps. 4 diodes usually makes a rectifier. Some missing ICs, TLP521, I'm not familiar with off the top of my head. See if we can see what that guy is. Not without the scope. And then connections out to our iron and our inputs. One of the things you often see with high voltage traces are a lot of spacing from one trace to the next. And for high current, you'll see thicker wires. The new standard that controls that is called IPC 2152, I want to say, has the equations for that. So you can get some estimates. All right, and then on the back side, you can see that we've got a lot of spacing. That keeps the devices from shorting out. Your standards are creepage and clearance, and that's in IPC 2122. That's a little weird, that little space there. I probably would have shifted that trace a little to eliminate that. I don't know if I needed to, but I probably would. Interesting little bits of solder run over. They must have done some mask cuts for that. And then once you get out of the high voltage area, once you break that down, you can start introducing your ground plane again. And that helps with heat dissipation. So not too complicated a board. A lot of big ground pours. Typically you would want to connect those if you have ground on the other side. You'd want to connect those so you don't have, you know, because this little area here, I mean, it could be an antenna if you have any switching going on. I imagine the switching on this device is all very, very, very low speed, you know. For the power, you know, it's 60 hertz. You don't have any worries. So interesting, interesting. So other than that glue stuff that I didn't like, looks like we max 4051 missing. So this thing looks like they had either some part substitutions that they could swap things out for, or it's got some added functionality that isn't introduced here. Yeah, another iron. Maybe they have variations of this that blow hot air. I don't know. But if you can use the same board, you can avoid all that. So all in all, pretty interesting teardown. I kind of had fun. I hope you did too. I don't know. But I do need your help. I need you guys to like and subscribe and hit the little bell if you want to get notified the next time Mark voids a warranty or Mark makes a mess, a new series you don't know about yet. Boom, boom, boom. Do you want to be there when it happens? I think you do. So like, subscribe. Let me know if you have any suggestions as we go through to improve Mark voids a warranty, or if you have any comments during each individual show. Once we get to 500 subscribers, and we're dangerously close, we're doing a special Mark voids a warranty where I take apart a production video camera lens. This thing is huge. The lens is the size of a dinner plate. But I can't do that without your help. We need to get to 500, which means we need 40 more people. Tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends, and have them visit Mark voids a warranty. I'd appreciate it. Thank you to our sponsors, Advanced Assembly and Royal Circuits, for making Mark voids a warranty happen every week at noon on Friday. We'll see you next week when we're taking apart, I believe it's an Amazon Kindle Fire. Should be a hoot. Take care. Bye.